Hello and welcome to part 2 of the Arduino Starter Kit. This is Sofox and right now I'm moving on to chapter 2, the Spaceship interface. Or it's another word for, let's have a lot of little nice lights flash back and forth, like this. See? It's pretty nice. So, let's get started. First of all, I have to hold this page open just so I've got a single guide. And then I take my board and I mercilessly rip out all the components that I don't need from the last exercise. So there is the resistor that I've since confirmed is actually 220 volts. It's got red, red, black, black, so that's red, red are 2, and black, black is 0, and 10 to the power of 0. So it's just, it all works out. Just trust me on that one, you know, like. And so we take out the switches, we take out the little wires from the last time, and then we will have a somewhat pristine board to work from. We'll leave in the connections, as always. This is the plus side over here on the left, and this is the negative side. Incidentally, they can sometimes be known as the cathode and anode. So, first things we do is we actually start by getting some LEDs, as we see. So, we get one LED here. Now remember which is the positive and which is the negative. There we are. We get the negative, 6, 10, another one there. As you can see, I'm actually putting them, straddling them between. This one has the positive in 6 and the negative in 7. And the third one will be a green one, because just to shake things up. And positive in 14, negative on 15. So there we are. Now we need to wire up the resistance. Now, philosophically, does it matter whether the resistance goes from the positive of the lead to the positive one, or from the negative of the lead to the negative one? And honestly, I don't think it really matters. And according to this, according to the book, they just have it going from the negative one to the negative. So let's do it that way. So one in the negative and one in the lower pin of this, so it's there. So that's 220 volts. Let's get another 220V. Well, actually, let's get two of them because we are crazy people and we want to take things to the limit. Same thing as before. Put one there in the negative, one there in the positive, and same with the green. One in the negative, and one in the negative side of the lead, and one in the actual negative area of it. Now we could just try to keep going on, but how about we test this just to make sure it's working, because testing is cool and making sure it's working is also cool. We take the positive and let's just tap it against the positive of this one. Oh, yes. Another really important thing, you might want to plug this thing in first and turn it on. Okay, now that it's actually plugged in, let's see if this actually works. So I press against the positive. Oh, that's a bit of an anti-climax bummer thingy. Oh, right. I had the resistor going from the ground to the positive part of the thing. So this is why you test it as you go. There we are. So what I'm doing is gently pressing it against the positive. Now I'm gently pressing against this positive, and it works. And gently pressing against this positive, this one. As you can see, once I attach the positive, it flows from the positive through the LED down to the negative. Then it uses the resistor and goes straight to ground. So it all works pretty much there. But that's only part of what we're doing. The next bit we're doing, oh wait, yes, this is where it gets interesting actually. We're not just plugging in the lights, we're plugging the lights not into the positive, but into 3 numbers. We're plugging the green into pin 3, then 4, and then 5. So the way it works is, of course, the Android is a bunch of pins. As you can see it here, there's 1, 2, 3, 4, 5, 6, 7, and so on. They're all digital pins. Now this is the key part of the Arduino. You can code them to actually output specific values. So let's quickly grab some more of those jumpers and actually plug these in the way they're meant to be plugged in. 3 will be plugged in to go to the positive of green. Next up, this 4 will be coded to go to the positive of the middle red. Here, let me just move it in a little bit. And finally, 5. Oh, damn it, let me. 5 is plugged in to the positive of the top red. Okay, so that looks pretty cool, but wait a sec, they're not lit up. Well, of course not. They haven't been coded to they haven't been programmed to give out these values yet. So, without further ado, let's make sure that that happens. Let's switch over to the coding part. Okay, so here we are, and this is what we've opened up. Here we have the Arduino development environment, where we can do all sorts of wonderful things to control the Arduino. Now, as you can see, the Arduino board is already selected, and it's already, it's already hooked up to that thing. So let's write our program. Now, I could quickly write through it myself, but instead I'm just going to quickly go to the blink just to get me started. There we are. Yeah, blink, modified, thank you Scott Fitzgerald and everyone else. Let's quickly go, let's just delete that so we actually have space for this thing. Don't worry, actually in real life you should really use attribution because it's really, really important. So, initialize the digital pin LED built in has an output. So, right at the moment we've got 3 lights. How about we make the green one? The green is pushed into pin 3, so let's make that 3, 3, and 3. So what it does is this setup runs when the Arduino starts up, and this runs in a continuous loop. So pin mode, we set 3 is our output, then we write 3 to high, wait 1 second, and then write 3 to low. So we are going to quickly upload and see where we go with this. Okay, so here it is, and it's working, kind of. I wanted the green one to pulse, but apparently the red one is pulsing instead. And that's because I've got this was wired. I meant this to go in 3, 4, 5, and looking at it, I seem to have done 4, 5, 6, 2, 3, 4. So let me just rewire these slightly, move them all up by 1. And move this one into 3 so that green should blink on and off. Yeah, there we are. So the way it works is, essentially according to my code, it waits 1 second, then sets it high, then which turns it on, then it waits a second and turns it low, so it blinks on and off. This green is clearly blinking on and off. So that's great starter, but we need to go another step further. Right now what we need to do is we need to actually get a switch into this system. And there's our switch right there. Now the way a switch works, as I've already mentioned, we'll start the switch at 22, is that a switch basically just makes a connection. So that sounds pretty cool, but how can we get it to control it? So in the previous exercise we had the switch directly on the line so that the electricity would go through the LED, then the switch, so when the switch was down it would go on, and when it was released it would go off, or the other way around, sorry. When it pressed down, the connection was made and the light would go on, and when you released it the connection was broken, the light would go off. But if we want to do sophisticated computer stuff, we need to actually have it so that when you press the switch, it sends a signal to the program, and then the program changes its behavior. So, yes, you connect the voltage, the plus, directly to the top of the switch, and then on the other side, you use a 10 kilo ohm resistor, that's really high, and connect it to ground. So, let me just quickly show you how this works. You take a really small one, like one of these, and you connect it from voltage from 22, which was one side of our switch, and put the other end into voltage. This thing is damn fiddly, you know that? Yes. You kids, get off my lawn. Okay, there we are. There we are. And I put the switch in the wrong position again. Okay, so now the positive of this is hooked up to there. Now we're going to hook it up from this switch side over to the to number 2. Now this is important. Up to now what we've been doing, these things have been actually, sending a signal. They've been outputting something. But now it'll read it. When we press this down, it'll connect this to voltage, and this will send the voltage. But if we press this down, then this will read and it'll say, hey, is this high or low? And when we press down, it'll be connected to the voltage, so it'll say, hey, this is like really, really high. So therefore, it'll be a 1. And when we release it, well, that's a problem. If we release it, it might be a 1 or a 0. So what we need to do is first take a 10 kilo ohm resistor, like this one, which we identified last time. We attach it from the ground of the switch, and then connect it to the actual ground here. So what this happens is that when we press this down, the voltage will go and this will be done to up, but when we release it, it'll be connected through this resistor to ground and go down. Now even though this is a high resistance, it still will pull it down. So when I press the button, there'll be so much voltage that it won't go through the resistor fast enough, so this will be as a 1. When I release it, all the voltage will drain out, go to 0, and then this will be a 0. This is called a okay, it's either a push up or a pull down switch. I honestly keep forgetting which one is which, but screw it. Let's move on. Let's move right back to the coding. Okay, so we're back here again. So as you can remember, we set 3 to output, and we had 3, 4, and 5 also as outputs. In other words, as LEDs. So this means that we can actually send an output and turn them on and off because we are outputting something to them. But of course, number 2 was a switch, and this case is an input. Now, let's actually follow the code and actually have this do something depending on when this operates. So the setup is run initially, and then this just loops constantly. So the first thing we do is we decide int switch state equals 0. That means that the switch is off. Switch state, and then it's equals digital read 2. This looks at pin number 2, which of course is the button, which we've set up as the input, and sees whether it's basically up or down. And it does this by checking the voltage. So the next thing is to actually see what it does in each circumstance. So if switch state equals low, that's if it's down, then do this. Else do this. So if it does this, so let's say, what do we want it to do? Well, when it's not pressed, the idea is that green is pressed, but the other ones aren't. So the green lights up when it's not pressed. In other words, the only way that you can have it not show green is by pressing the button. So, set to green, 3, 4, 5. That's green is high, and the other 2 are low. So by default, the green light will be on just as a matter of course. So then there's the question of, well, what happens if we do press that button and then it goes down? Well, the way it works is, for a start, it flashes between the 2 red buttons. So what it does is, let's start by making sure that green is low, and then this is high, which is one of the reds, and the other is low. And then let's wait a few seconds and then just switch it so now this one is low and this one is high. So basically it switches between the 2. Now if I set it up like that, you kind of really won't see the difference because it will go through the 2 so quickly. But the simple thing to do is just insert a delay, just like over here. Now these are measured in milliseconds, so 1000 is 1 second. Let's turn it to 1/4 of a second, just like the book tells us to do. And good. Let's first of all click the tick mark to make sure that it actually, I didn't include any terrible mistakes that will ruin the program. And then if this works, look, it seems green, then let's compile it into our program and let us see what the eventual result is. Okay, so we've written it in, and first thing we look at is that the green light is on. It's not flashing, it's on. So this was according to our program. So the ideal thing is that if we press this button, the reds will flash between each other. Let's see if this actually works. Oh, and it kind of does. And you want to know some... Oh, cool. So it does actually feel like some cool sci-fi thing. And you want to know an extra little bit? The kit comes with this little bit of card, which looks pretty innocent. But if we manage to put this in the right way, it can give mild amounts of amusement. You know, there we are. Ooh. There we are. Ooh, fudge a sec. Nope, I got it. Ooh, yeah. There. Ta-da. There. Now it's like its own little control panel. I have a huge future ahead of me in designing sci-fi set pieces to be used as props in TV shows, which of course won't happen because they'll all be replaced by CGI. Anyway, that's a pretty cool thing. And the rest of the chapter, as you can see from the code, it gives details on the codes that we just entered in. And of course, once again, there's that whole diagram for this. But, you know, and I think it's a pretty fun exercise. Okay, and that's, yeah. So the next one is the Love-O-Meter, which I hope won't reveal any embarrassing secrets about it. So there we go. That is the Spaceship control system, Spaceship interface.